let's calculate the value of pi to any precision. So this is going to be the proof of the limit that we will be getting. If you just want the limit, then skip to the end. If you want the proof as to how I derived the limit, then keep watching. So let's take a regular polygon with x sides and let's circumscribe and inscribe a circle around the polygon. Let's denote the radius of the circumscribed circle and inscribed circle as a and b respectively. And as you would see, this is a and this is b. So we can just make line segments going from the center of the polygon, center of the circle, to the corners of the polygon. So now what we can do is that we can just so we can see that there's x as many triangles that are formed by these line segments. So we can just take one of these triangles. Also note that all of these triangles are isosceles and equal. See, because these two are equal, these are the radii of the circumscribed circle, which is equal to a. So this is our triangle, our isosceles triangle, a, b and c. This is denoted that way. This is equal to a and this is also equal to a. Let's drop a perpendicular. And you would also notice that these two are congruent, right? Because, well, this is 90 degrees, these two are equal. This is also going to be 90 degrees, right? This angle is 90 degrees. And this is equal. So these two are congruent because of RHS criterion of congruence. So area is equal to half into base into height. So now what we can do is that we can take half of this triangle. Let's take this half. Alright. So if we take half of this triangle, we see that this is equal to a, this is equal to h, c and d, and let's call this angle theta. So you would see that this is half into base because this was the base and this was half of the base because these two are congruent. So this is so this would be a into sine theta. Sine theta is opposite upon hypotenuse. A is equal to the hypotenuse, so opposite would be equal to a sine theta. Now theta is nothing but a divided by 2 because, well, this bisects this, right? And this is just half of this full angle. So theta is equal to a upon 2, but what is a? Well, a is nothing but the entire angle, which is 360 degrees. It's called 2 pi in radians. It will be a lot nicer, and so you'll see in the future. So let's just call it 2 pi radians, and a is just 2 pi upon x because there's x triangles and there's and all of these triangles are equal, so all of these have little a's inside them. All of these are equal to a, and this is 2 pi upon x, so half of a would be pi upon x, so it's pi by x. So we just need to do a sine pi by x, that's base by 2, it's multiplied by the height h, and see, h is just this line segment from the center of the inscribed circle, which is the same as the center of the circumscribed circle, to this bit. This is the side of the, actually this is just, yeah, this is the side of the polygon. So let's just look at it going from here to here. There's infinitely many radii obviously, but it's just denoted that way. So this is going to the side of the polygon, right? So this is just equal to our h. See, this is our h, this would also be our h, you see. So as we said, the radius of the inscribed circle is b, so this is just ab sine theta, and theta is pi by x, so this is AB sine pi by x, which is the area of one triangle. So the area of the full polygon is x AB sine pi by x because there are x triangles. And this is the most important part. When we increase the number of sides, the polygon gets closer and closer to a circle. And we can assume that at infinite sides, the polygon would become a circle. So at infinite sides, the circumscribed circle would be equal to the polygon, which would also be equal to the inscribed circle. Let's call the radius of the polygon, which is now a circle, be equal to r. So a is equal to r is equal to b. let's replace the values inside this. X r square sine pi by x. This is equal to the area of a circle of our polygon, but this is called a circle for the sake of convenience. And this is at x is equal to infinity. So you can write it as area is equal to limit as x approaches infinity of x r square sine pi by x. And this is the area. So what is the value of pi? Well, pi r square is the area of a circle, and there's r square on both sides, and in the x world, r square is just a constant. So you can take r square out, there's r square here, they get cancelled. Pi is equal to limit as x approaches infinity of x sine pi by x. You can verify this on Wolfram Alpha. The only reason I decided to use pi in radians instead of using degrees was because, well, it's easier to check it on Wolfram Alpha. That's the only reason. You could use degrees if you wanted to, it doesn't really matter. You can write this as 180 degrees upon x, it really doesn't matter. You can write it anyway, it still holds true. Thank you.